In this video, I will explain you the drawbacks of intrinsic semiconductors. We have seen that intrinsic semiconductors is made up of the same element, right? So with silicon intrinsic semiconductors, in the crystal we can only see silicon atoms. Now silicon are bonded with 4 nearby atoms to have 8 electrons in the outermost orbit, okay, in valence orbit. Now on rise of temperature, these electrons will get higher energy and they would excite, they would move from its lattice point to conduction band. Okay, these electrons are free electrons that will move, that will contribute towards conduction. Now, what are the limitations of intrinsic semiconductor? One thing is the definition itself. See, when we are increasing temperature, it gives more number of free electrons and thereby conductivity would be higher. Now here I am keeping a semiconductor. Okay, let's say I have made my mobile phone using intrinsic semiconductor. Here let's say now the temperature is 27 degrees Celsius. A value of current is passing through my device. But at night the temperature would be lower as compared to now, and it may be 24 degree or 23 degree, but the value of current would be a different value. Now if I am taking into a place where the temperature is very low, that would behave as insulator. So there is no use of my mobile phone at that place because it cannot send signal or current from one position to another position. Okay, I can't use the mobile phone. Now if I am going from Delhi to maybe Dubai, it is having two different temperature range at these two places. Here it is lower, there it is higher. Now the same device, now at Delhi it would behave as something and at Dubai it would behave as something else. Okay, the value of current would be different and performance would be different at these two places, which is not acceptable, right? So current is controlled by temperature, not by us. We have no control over the current. It's the temperature that decides what should be the current passing through intrinsic semiconductors. Higher the temperature, more number of electrons in the conduction band and more would be the conductivity and more would be the current. Next thing is current is very small. At room temperature we know that only less number or very few number of electrons would be there in the conduction band. Okay, at room temperature, though there are many electrons excited to conduction band, but these electrons won't be sufficient to make a larger current. Okay, there are electrons in the conduction band, but these are not very sufficient to make the larger current we are looking for, because we know current is equal to NEAVD, where N is the number of electrons per unit volume, that is per meter cube. We need this value higher, then only we can have higher amount of current to send through an element, which is difficult with intrinsic semiconductors because charge carriers is very less, number of charge carriers is very less. So whatever may be the area or drift velocity, the current made by those electrons would be very less because number of electrons are less. Okay, so current is very small. Now to overcome this, how we need to overcome? We should be able to control the current, right? And next thing is we need large number of free electrons even at room temperature for the contribution of current. Okay, so these things would be done with the help of doping. Now I can say that this is a pure crystal. Pure crystal means the entire crystal is made up of the same element. Now when we are adding different atoms, for example here I am going to add an aluminium atom and maybe a phosphorus atom or a different element, then this semiconductor from intrinsic semiconductor, that would become extrinsic semiconductor, and those are impure semiconductor. The impurity means we are adding an element which is outside this silicon. Now it is made up of only silicon atom, intrinsic semiconductor, completely pure, but now when we are adding a different element, then that become impure, or I can say that it is extrinsic semiconductor, but we are doing that conversion for these two drawbacks to cover. Okay, so we will see that is extrinsic semiconductors in coming lectures. Okay, thank you.